All right, everyone, let's talk power management. We all know the struggle, right? Your phone battery drains way too fast, your laptop turns into a furnace, and don't even get me started on gaming PCs. Just like we try to conserve power in our homes, our devices need to do the same to maximize efficiency. That's where power management swoops in to save the day. Think of it like this. You wouldn't leave all the lights on in your house when you're not using them, would you? That's just wasteful. Similarly, your devices shouldn't be running at full power when they're just sitting idle. Power management is all about optimizing power consumption by intelligently adjusting performance based on usage. This is especially crucial for AI applications, which are notorious for being power-hungry beasts. Imagine running complex AI models on your phone without proper power management. You'd be tethered to a charger all day. That's where AI kernel drivers come into play. They're like the unsung heroes of the AI world, silently working behind the scenes to keep your devices running smoothly and efficiently. Now, you might be wondering, what the heck is a kernel driver, Linus? In simple terms, it's like a set of instructions that tells your computer's operating system how to interact with specific hardware components. In this case, the AI kernel driver acts as a middleman between the AI applications you use and the hardware that powers them. These drivers are responsible for a ton of important tasks, but one of their primary functions is power management. They're like the power-saving ninjas of your device, constantly monitoring system usage and making adjustments to ensure optimal performance without draining your battery life. Think of it like a conductor leading an orchestra. The conductor, AI kernel driver, carefully observes each musician, hardware component, and adjusts their performance, power consumption, based on the music being played, AI application demands. When the music calls for a powerful crescendo, the conductor directs the musicians to give it their all. But during quieter passages, the conductor instructs them to dial it back, conserving energy for the next big moment. So how do these AI kernel drivers actually monitor system usage? Well, they're constantly gathering data from various sensors and components within your device. Think of it like a fitness tracker for your computer. They keep tabs on things like CPU utilization, memory usage, and even the temperature of your components. By analyzing this data, the AI kernel driver can get a clear picture of how much power is being used and, more importantly, how much is actually needed at any given moment. It's like having a built-in efficiency expert that's always looking for ways to optimize performance without wasting precious energy. For instance, let's say you're just browsing the web on your laptop. The AI kernel driver recognizes that this task doesn't require a lot of processing power. So it cleverly throttles down the CPU, reducing its clock speed and voltage. This is like dimming the lights in a room when you don't need full brightness. It saves energy without sacrificing too much performance. Now, here's where things get really interesting. AI kernel drivers don't just adjust power consumption on a linear scale. They can actually switch between distinct power modes, kind of like shifting gears in a car. These power modes are optimized for specific levels of performance, ranging from ultra-low power for idle states to full throttle for demanding tasks. The transition between these power modes is seamless and happens automatically in the background, thanks to the AI kernel driver. You won't even notice it happening, but you'll definitely reap the benefits. It's like having an invisible co-pilot who's always anticipating your needs and adjusting the car's performance accordingly. For example, let's say you're watching a movie on your phone and suddenly you receive a notification that requires some heavy AI processing. The AI kernel driver detects this increased demand and seamlessly switches from low power mode to a higher performance state, allocating more resources to the AI task at hand. Once the task is complete, it smoothly transitions back to the low power state, conserving battery life.